Hello. Today we're actually going to go through and look at how to be able to do some longhand electron configurations. We started looking at this last week and we're going to be continuing it this week along with shorthand electron configurations, but we've got to make sure that we really feel comfortable knowing how to do longhand electron configurations. So I'm going to do two examples with you and then show you, if you're given the configuration, some ways to be able to get the answers for those in the hopes that it will actually help you be successful with your test this week. So the first question that we have is writing the longhand electron configuration for chlorine. So if we go and look at chlorine on our periodic table, chlorine is element number 17, right? So chlorine contains 17 protons and 17 electrons. So for looking at electron configurations, the only subatomic particle that we're actually worried about here is just the electron. So if we're looking at that, we want to be able to say where in terms of an energy level, where in terms of an orbital, and where in terms of the number of electrons are these 17 electrons that chlorine possesses that are circling around outside the nucleus of its atom. So if we kind of look at our rules for how to be able to look at the periodic table and utilizing this periodic table that we set up last week, we can see that there are kind of four different locations where the electrons could potentially exist within an atom. And we called those sublevels or orbitals S for the elements that have electrons that kind of exist on the far left of our periodic table, sublevel D or orbital D for the elements that have electrons that exist in the center of our table, and then for the ones that kind of exist on the far right of our periodic table, we call those P, and then the ones that are at the very bottom of the periodic table exist in sublevel or orbital F. Right? So how do we actually use these to help us get to chlorine, right? Which is the 17th element on our periodic table. So we kind of have to have some rules that help us know how to actually even start an electron configuration. So our rules, if you will, kind of look like this. So we always have to go in atomic number order. So if chlorine is atomic number 17, we're going to be working with element 1 through 17 in order to help us get there. And then 1, if the element is not in a particular location, sublevel, or orbital, we're going to go to the end of that orbital and write down the last piece of information. But if it is in a particular location, meaning the orbital or the sublevel, we will only write down the information for that element, and we are going to stop when we have written down the information for the element that we have requested. Right, and that is a picture of one of my scars. We definitely don't need that when we write it down. This is how we are going to write it down and the information that goes with it. It is always 3 pieces of information. The first piece of information tells us what period, row, or energy level we're on, and that particular value can only be value 1 through 7. And that kind of comes from right here. So like what if we're going across the periodic table, we can either go across on any of these particular periods, rows, or energy levels that are labeled 1 through 7. So that is what the first number kind of pertains to, is which period, row, or energy level are we on at the particular time when we are working through a portion of our electron configuration. The second part is always a letter that basically tells us what orbital we're in. And because we are not focusing on F, we're basically, that letter is either going to be S if we are on the far left, P if we are on the far right, or D if we are in the center. And so that relates to kind of where on the periodic table are we. Far left, which is S, far right, which is P, or in the center, which will be D. All right. And then the last part is the number of electrons that we actually have. And if we are in S, the number can be no larger than 2. If we are in P, the number can be no larger than 6 that we are putting up here, which kind of looks like an exponent, but it isn't. And if we are in D, that number can be no larger than 10. So where are those numbers coming from? Well, if we go back to this particular diagram, we can see that in S, the only numbers that we happen to see up here that are looking like exponents are 1 or 2, but we do not see anything when we have an S that has a number that's larger than 2. When we are in P, we can have a P kind of exponent, or at least what looks like an exponent, that can be any value up to 6. And if we are in the center of the periodic table, that number can be no larger than 10. Right? So it's basically kind of the way that the periodic table is actually constructed, and it also has to do with the number of places that our electrons are allowed to be within that particular area. And once you kind of fill up that area with electrons, you cannot have any more than that. All right, so back to our practice. We are looking at chlorine, and we are starting at the top of the periodic table. So when we start, we look at the first energy level, which is basically where hydrogen and helium would be. So in neither place do we find chlorine, right? Which is exactly what Rule 2 tells us. So Rule 2 basically tells us that if we're going past the butterfly, let's actually go back, that if the element is not in a particular location or that orbital, we're going to skip to the end of that orbital and write down the last piece of information. So if we go back here, and this is kind of the first orbital that we're looking at, and chlorine is not either element 1 or 2 on the periodic table, the first piece of information that we're going to write down is that we looked in energy level 1 and we looked in S2, and the electrons for chlorine, okay, are not there. Those 2 electrons for chlorine we checked. All right, so we're going to write that down first, and we're going to say, yep, we looked in 1s2. Right? Following along in our atomic number order, these are the next 2. This would be element number 3 and 4. And we take this together. So you kind of do an orbital location at a time. So what energy level are we on? We're on the second energy level. We're in S. These 2 belong to lithium and beryllium, so they don't belong to chlorine. So again, following that rule, it says jump to the end and write down this piece of information. So we're going to write down 2s2. And so that will be the next group of 3 that we are writing down for our electron configuration for chlorine. Not really quite sure why it's not letting me type it out in a straight line, but you should be writing it out in a straight line, and for some reason it's not letting me do that. So if I just have to keep putting them underneath each other, then I will. But you should know that really it should just be in one straight line. All right, so I've got 1s2, 2s2. We're going back to our periodic table. And now we're going to take this whole section right here, elements 5 through 10. But again, we see here that elements 5 through 10 do not contain chlorine, right? So if we're going to go back to our orbital map, we can still see that we're on the second energy level. Chlorine isn't in either one of these. So like the rule says, we're going to jump to the end. And the grouping that we're going to write down is 2p6. Right, so I'm going to actually put that in. Nope, it's not going to let me keep it there. So my next grouping of 3, yikes, is going to be 2p and then 6. And then we are done with the first 10 elements, so the first 2 rows. But we are still not to chlorine. So now we have to move to the third energy level. And if we go back to our periodic table, right, the third energy level gets us to sodium and magnesium. Chlorine is not here either. So again, our rule basically says jump to the end of this particular orbital, and the end of the s orbital gets us to s2. So we're on the third energy level in s2, so we are going to write down 3s2. Right? And now that we've gone through 12 elements, we still have to keep going because we haven't gotten to chlorine, and we take this whole next orbital section, which would be in P, elements 13 through 18. And here, chlorine is in this region. It's kind of hanging out with the elements that exist between aluminum and argon, right? So if we go through this, right, and we look at our rules, 3 now says if the element is in a particular location or an orbital or a sublevel, right, only write down the information for that element. So we have to know which element chlorine is within this particular P area. So if we go to the periodic table of elements, we can see that chlorine is the 1, 2, 3, 4, 5th element over, which then, what information do we need to grab for it? Well, it's on the third energy level, and it was the 1, 2, 3, 4, 5th element over, so it's right next to argon, which was at the very end. So what we need for chlorine is just 3p5. Right, so we're going to write down 3p5, and then the rules actually say that we can stop when we've written the information for the element requested. So we got to chlorine, we wrote down its element as 3p5, so we should be done, right? But let's see if that electron configuration that we wrote for chlorine is correct. So what we have is 1s2, 2s2, 2p6, 3s2, 3p5. Okay, so one way to check is that we could look at this last grouping and we could see that it says 3p5. So what does that actually tell us? The 3 tells us that we are on the third energy level down on the periodic table. So we can count down 1, 2, 3. The next part tells us P. P would tell us that we should be in the sublevel or the orbital that is on the right-hand side of the periodic table. All right, so it's labeled as such. P is over here. All right, so we would move to this region, and then the last piece of information, which looks like that exponent, tells us chlorine should be the 5th element over in the p orbital that's on the third level. All right, so we count 1, 2, 3, 4, 5, and chlorine is indeed the 5th element. So the idea that we stopped with 3p5 is one way to let us know that we did it correctly. The other way that we can check is that these numbers, which are telling us the number of electrons that happen to be in a particular orbital, should always equal the atomic number for a particular element. So if we add 2 plus 2, which gives us 4, plus 6, which would give us 10, plus another 2, which would give us 12, and another 5, which gives us 17, the atomic number for the element that we're looking at, which in this case is chlorine, should match that number. The question becomes, is chlorine's atomic number 17? And the answer is yes, it is, right? So we are, fairly confident that the electron configuration that we have written here, 1s2, 2s2, 2p6, 3s2, 3p5, is indeed the electron configuration that we need for chlorine. All right. Now, the other way to be able to look at it is here's one for sodium, And you could try the electron configuration for sodium. And if you're in my class, I would love to be able to see what you come up with for sodium as the electron configuration. If you are watching it for another class, why don't you try sodium and then you could show it to your teacher and either he or she could give you feedback on that, right? But what about if it works the other way? What about if either myself or your teacher gave you an electron configuration already and said, what element is this the electron configuration for? How would you know how to do it? All right. And again, this is not letting me type all of it in one continuous line, which is exactly how it should be written, right? But if we were looking at this particular electron configuration, which is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, one of two ways that you can actually do it, right? The first one, like I said before, is that you can go to the very last grouping of 3 and look at where it is telling you to go on the periodic table. So this one says you need to be on the 4th energy level. So if we go to the periodic table, we can count 4 down, 1, 2, 3, 4, right? So it's got to be somewhere on this particular row, right? Then the next part, okay, tells us that we should be in an s orbital or an s sublevel. And if we look at our periodic table, the left-hand side of our periodic table is where the s's are. Right, the only exception to that is over here, but that's on energy level 1. And so in this problem, we are on energy level 4. So we're either going to be right here or right here. And then if we go back to this one wants the first element that's in the s orbital, right? So we want the element that is right here on the periodic table. So we go periodic table and we count 4 down, 1, 2, 3, 4. And then this is the s orbital, and this is the first one. We should be looking at potassium or K as our element. Now, how do we know for sure that potassium is the element that we want? And this is the other way to check to make sure that you have the right answer. All right, again, you can use these numbers right here, which look like exponents but aren't, and you can add them all up, okay? Because all of the numbers there should be telling you and accounting for all of the electrons that are in the particular atom that you are doing the electron configuration for. So if I take 2 plus 2, get 4, plus another 6 is 10, plus another 2 is 12, so another 6 is 18. And then if I add one more, my atomic number should be 19 because that would tell me that I have 19 electrons sitting outside the nucleus of this particular atom. So what element on the periodic table has an atomic number of 19? It is indeed potassium, right? So if you want to practice one, here is one where you could actually look at and see what element on the periodic table would have an electron configuration of 1s2, 2s2, 2p6, 3s2. And if you're in my class, you can tell me what element would have this electron configuration. And if you have a different chemistry teacher, try it out and then let your teacher be able to give you some feedback on your progress. Thanks so much for stopping by.